Okay, let's work through some exercises where we classify and answer some questions about different real numbers. Now, one thing we want to do is we've been defining natural numbers rather than what the worksheet here is calling whole numbers. So let's change. We're going to change wherever we see whole, we're going to change that to natural. Okay, we want to take the list of numbers given to us and put it in the correct set. So let's take negative 6. Well, negative 6 is the 6 part is a whole number, all right, but it's negative. So it can't go in the natural numbers because those are only positive. So we're going to put negative 6 in to the integers. 2.73, we've got a terminating decimal. Well, it's not a whole number, so it can't go in the integers, but it is rational because it terminates. So we put 2.73 in that rational set. 3/7 is also rational. It's the fraction of two integers. Square root of 2, if you plug that in your calculator, you're going to get a decimal that does not terminate and does not repeat. So that goes in the irrational numbers. Okay, square root of 9. We might think that that goes in the irrational numbers because it's a square root. But if we simplify that, then that is going to be a 3, which is a natural number. It's a number we use to count with. It's a positive whole number. All right, negative 100. Well, the 100 is a whole number, but putting that negative in front of it means that it goes in the set of integers. All right, 0 also is an integer. It's not included in the natural numbers. Next one, pi. That is an irrational number, non-repeating, non-terminating decimal. The number 1, that is a natural number. We use that to count with. It's positive. All right, negative 1/2. All right, it's not a whole number. We can't put it in the integers, but it is the fraction of integers, so we can put that in the rational number set, as is negative 3.8. And the next one, 5.42. We got a repeating decimal. Putting that line above the 42 tells us that that is 5.42424242, and that just continues to infinity. A repeating decimal, so infinity. Okay, the last one there, we have a decimal that doesn't appear to be terminating, and it doesn't appear to be repeating, so that goes in the irrational number set. Okay, notice that we have, put these numbers in the sets that they belong, but every single one of them is real. So all these numbers are real. We just have kind of categorized them in the separate sets. Okay, let's look at these next true or false questions. And we've got a couple of whole numbers that we need to change to say natural. So let's go ahead and do that. And we can also use our Venn diagram to help answer these questions. So all natural numbers are integers. Well, if we look back at our Venn diagram, natural numbers are completely included in integers. So that means every natural number is an integer. So that's true. All right, number 2 flips that around. It says all integers are natural numbers. Well, if we look at our Venn diagram, all right, we have 3 integers here that are not natural numbers. So that right there tells us that that's false. Number 3, some rational numbers are integers. So again, looking at the Venn diagram, here we've got integers, and they are inside this bigger rational numbers. So we have a true statement there. Okay, number 4, we got a whole number there that we want to change to say natural, and we got some natural numbers are irrational numbers. Well, if we look at our Venn diagram, here we've got our natural numbers. Over here we have irrational. You see that there is no overlap whatsoever between those two sets. So there cannot be any number that's both in this circle and this oval. So that would be false. Okay, here we're going to take the numbers in this list and we're going to write down which one goes in each of these sets. So first we'll change this whole to be natural. All right, let's go through that list. Well, we've got, this is not a natural number. Negative 18 is not. 0 is not. That is not. That is not. That is not. Oh, 5 is. Looks like that's the only one. So we'll list out 5. We go to the next set, integers. Well, all natural numbers are a part of integers, so we can include that. Let's see what else is an integer. So we go through, that's not, but negative 18 is, and 0 is. And we've already included 5. So it's just going to be negative 18 and 0 that we add to that list. All right, now going down to rational numbers, all integers are rational. So we can just automatically put those numbers in that list for rational. Let's look at what else is going to be included. All right, well, here we've got 4/5. It's a fraction of 2 integers, so that'll be included. That is not. Negative 1/2 is rational. So is this terminating decimal, negative 2.01. We already have 5. Pi is not rational, but we've got a repeating decimal here, so we'll include that. Okay, so we get the 4/5, the negative 1/2, the negative 2.01, and the 2-point repeating 513. All right, now we're going to move on to irrational. Irrational and rational there's no overlap, so we're not going to include any of the numbers that are rational in this list for irrational. In fact, it's just going to be the numbers that aren't in that list. So we list those out. We've got, that's where the square root of 5 will end up, and pi, and that last number on the list, that non-terminating decimal, 5.1823159, ... All right, next one says real numbers. Well, that is all of them, right? We don't have any negatives under the square root, which is how we get a non-real number. So they are all real. Okay, we're going to do just this one more thing. We're going to ignore that last true and false part. Here we want to go through each of these numbers and just check off which of those sets they belong to. Okay, whole numbers, which we want to change that to say natural. Negative 7 is not natural, but it is an integer, and then that means it's rational and real. Okay, 3/4, not a natural number, not an integer, but it is rational, so it is also real. Square root of 2, not natural, integer, or rational, it's irrational, and it's real. 5, that is a natural number, and so it's an integer, and it's rational, and it's real. Last one, this terminating decimal, 0.398. It's not natural, it's not an integer, but it is rational, so it means it's also real.